Okay, so today we're going to talk about 10.3, Statistics Numerical. Okay, this will be the first part. So that's about what did we talk about 10.2? In 10.2 we talked about the graphical ways to talk about statistics, and we talked about stem and leaf plots, the split stem and leaf plot, the back-to-back stem and leaf plot. Then we also talked about a frequency table, and from that, how to generate a histogram. Okay, so we're going to talk about the numerical stuff today. Okay, so when you talk about a statistic in a distribution of statistics, you're going to talk about three things. Okay, we're going to talk about four things. So I'll toss the fourth one in also, which is not in the book, but you need to remember it anyway. So we're talking about the shape. So the pneumatic is socks, right? Shape, outliers, center, and spread. Okay. Shape is whether it's roughly symmetrical, whether it's unimodal or multimodal, right? It could be bimodal or even trimodal, right? Outliers is whether or not it has an outlier. Center is we talk about the center, and there are three things that we can talk about here. We can talk about either the median, mean, or mode, and you've learned these, okay? So briefly, median is the one right in the middle. Mean is you add them all up together and divide it by the number of how many different ones you have, basically the average, right? And the mode is the one that shows up the most, okay? So the spread is from the max to the min. What is the variance? How spread out is your data? Okay, so these are the four things you need to discuss if you talk about the distribution. All right. Another thing we talk about shape is we talk about being skewed right or skewed left. Remember we said that this guy is skewed to the right. So this is skewed to the right. Okay. And this guy here would be skewed to the left because it's skewed towards the left. You are skating down towards the left, right? So again, skewed to the right, skewed to the left, okay? All right? So these are the four things you would need to discuss when you talk about the shape of a distribution, okay? So let's talk about the median, okay? The median is the one that is in the middle of your distribution, the number that is in the middle, right? Okay, so let's go ahead and see if we can do example number 2. In example number 2, it says, find the median of the annual home runs of Roger Maris's Major League career. Okay, so we have the 12 numbers here. We have 5, 8, 9, 13, 5, 8, 9, 13, and then you have 14, 16, 23, 26, 14, 16, 23, 26. And then we have 28, 33, 33. And then we have 39 and 61. Now, obviously, these numbers are in order. You have to put them in order to find which one comes in the middle, right? So we start from the outside. We go in one, in one, in one, in one, and in one. And look right here, we end up with a situation where we do not have a number that falls right in the middle, right? Because there are even numbers. So when you are in even numbers, if you have even numbers data points here, your median is going to be in between these two. In other words, the median is going to be this guy. So you would have to do 16 plus 23, which is 39, divided by 2. So your median is going to be 19.5, okay? Let's say there was another number. Let's say that we had 3 here. Okay, then what? Then you're going to have, from here, and you go in one, in one, in one, and another one. And this guy here is the median. So your median is going to be 16. So if you have an odd number, you're going to actually get a data point, all right? If you have an even number, you're going to go ahead and do the middle like we did over here, okay? All right? So that's how you find the median, right? The median is that way. All right, so if I ask you to do the median, so what are the things that usually happens? How do you have an error? What do you go wrong? Where do you go wrong here? Is usually you do not end up, you do not write a data point in there, right? So you count them and go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you want to make sure you have all the data points, okay? So that's one thing that you should always check to make sure you have the correct data points, okay? So from here, let's go and see if we can find what a 5-number summary is. A 5-number summary is, you get the median, or you got the median here was 19.5. So that is the median, right? That's the median, okay? And then the minimum and the maximum, okay? So your median is going to be 19.5 here, right? Okay? So you have 1, 2, 3. And then the next thing you do is you find what is called the Q1 and the Q3. The Q1 and the Q3. Q1 is the median of the bottom half. The median of the bottom half, right? So you're going to go from here to here to here, and you go in between here. So the median is going to be 13. So the median, so it's between 9 plus 3 divided by 2 is 11, right? Then over here, you're going to have here, here, and you go in here. So you're between 28 and 33. So you're going to have what? Looks like you're going to have 61. So it's going to be 30.5. So this is your 5-number summary here. So your 5-number summary would be 5, the minimum, Q1, 11, and then you have 19.5, and then you have the Q3, which is this guy, and then you have your maximum. So this here is the 5-number summary. Okay? And from the 5-number summary, then you can go ahead and draw what is called a box and whisker plot. So the box and whisker plot is drawn in a way that you go like this, and this is 5, 61. So this would be about 19 and a half. So this here would be 19 and a half. This guy here would be 11, and this guy here would be 30.5, okay? So this is your box and whisker plot. This is because there's a box in the middle, and there's whiskers on the end, okay? All right. So what can we say about this when we look at this? Well, what does this mean? This means that 25% of our data is between here and here. Another 25% is here and here. Another 25% is here and here, and the other 25% is here, okay? So in other words, you are guaranteed to have 50% of your data within the box, okay? All right, so that's something that comes with the box and whisker plot, all right? So this can be cumbersome at times, right? So if I gave you like 35 points, this is quite a bit of stuff here, right? So an easier way to do that is to use your calculator, okay? So when you do the calculator, how would you find the 5-number summary? You would actually go ahead and take these numbers, populate it in your L1, okay? How do you populate in your L1? You go to Stat, Edit, right? You go to Stat, Edit, and then go ahead and populate your L1, and then you would do Stat, Calc, and then do, from the stat calc, you would do a 1var stat. Okay, if you do the 1var stat, it'll give you all 5 of these numbers. It'll just spit it right out for you, okay? Again, when you do that, part of the numbers that you get from the 1var stat is the number of data points. So you want to make sure, again, that your data points, that you have all data points, right? And the way to do that, I mean, right? To make sure you have, if you have 35, you want to make sure that at the end, when the 1var stat spits out all the data, that your n is going to be equal to 35 indeed, right? So, because if that does not match, that means that you have missed a point. You did not input a point, or you put one too many, or whatever it may be, right? Okay, so make sure And when you do the one bar stat year, that your N is correct. All right. Let's see. So comparing box plots. When you compare, you would just compare. You would write about it, right? Okay. And so that is the box and whisker plot. Let's see if we can go into. Let's see if we can compare it. So we go to example number 5. It says draw the box plots for the male and female life expectancy data on example 3 and comparative distribution. So if you look on figure 10.17 on the left-hand side of page 707, it gives you the 2 different box plots. So what can we say from the box plots? Okay, you have the box plots there, and they're little. There's a blue dot and there are 2 red dots. So those little dots there are outliers. Okay, that means that those are outliers, and if you find an outlier, that outlier gets separated, and we do not count that when we do the box and whisker plot because it skews the data. It distorts the data, so we get rid of the outliers. Okay, if you look at the box plots, what can you say? You can say that the spread for male is a little larger than the spread for female, right? That's the distance between the whiskers, right? So the male has a larger spread, and you can see that the median age for the male is smaller or shorter than the female. In other words, the female is going to outlive the male, right? Okay? So you can make those type of statements when you compare the box and whisker plot. Okay, so how do you calculate the outliers? Okay, the definition of an outlier is if it is outside of 1.5 times the IQR. Right. Well, then the obvious question is then, what is the IQR? IQR is the range of the intermediate quartile range. So it's the range between the 2 quartiles, Q3 and Q1. So on this one, the interquartile range is going to be what? IQR is going to be always Q3 minus Q1. Q3 is 30.5. Q1 is 11. So the difference is going to be 19.5. So if your data point is outside of this from each end, this end and this end, in other words, if the high is 1.5 IQR over here, then it's considered an outlier. So if I add the 19.5 to here, what do I get? I get 50. So 61 definitely here is an outlier. Okay, it's an outlier, all right, because it is greater than Q3 plus 1.5 IQR. Right? This is on the high end, right? On the low end, you would go from Q1 and you have to subtract out this way, right? So it would be Q1 minus 1.5 times IQR, okay? So I guess I did not do that right? So if I 1.5 to do 1.5 this, right? But even if I do 1.5, I'm still going to be very close to that being an outlier. Okay? So what would the IQR be? So IQR is 1.5, so what times 1.5? 1.5 times 19.5 is going to be 29, somewhere close to 29, all right? So 29. So if we add a 29, it's 59.5, so this is still an outlier. If I go less than 29 from 11, I'm going to a negative number, so you can't obviously have a negative number of home runs. So there is no outlier on the low end, okay? So if you go to page 706, bottom there's a purple box there, okay? A number of a data set may be considered an outlier if it is more than 1.5 IQR below the first quartile, or 1.5 IQR higher than the Q3, right? Okay? So, this is your definition of an outlier, okay? This is how you define whether or not you have an outlier. So now we can actually look and calculate to see if something is an outlier or not, all right? Okay, so we'll do the mean and the normal distribution in the next lecture. Okay?